Okay, Assalamualaikum warahmatullahi wabarakatuh. Good day to Dr. Rahisham and my fellow friends. Okay, my name is Ilyana Binti Mazuki. My metric number is CE190180. Okay, today I would like to present about group project. Okay, first, my part is introduction. Okay, for general summary, first, this project highlighted the insulator's design expertise. Okay, second, the applications of protection, equipment, size, and length calculation, estimation of performance, and installation of HVDC insulators is highlighted. Okay, third, there are many different types of overhead insulators, including composite insulators, porcelain insulators, glass insulators, pin insulators, and so on. Okay, lastly, the design may differ and the product range varies according on the dimensional, mechanical, and electrical requirements. Okay, for problem statement, okay, first, when it comes to qualitative insulators, the measurement of the electric field distribution is important because of flashover events. Okay, second, it can cause transmission network failure, are more common in polluted insulators. Okay, third, in practice, the distribution and total of contaminants deposit on the insulator surface is non-uniform and largest depend on the nature of the environment. Lastly, this project is to analyze the electric field distribution on the surface of porcelain. This insulator with and without the contaminants of environmental effect. For objective, the main objective of this project are first to construct a model of an insulator for a 132 kV transmission line powered by using console multiphysics software. Second, to analyze the performance of an insulator by using finite element analysis (FEA). Third, to analyze the impact of the environment on the insulator's performance. Okay, lastly, to determine the most suitable high voltage laboratory test setup. For scope, the scope of this project are as follows in order to achieve the state objective. Okay, first, the simulation is using console multiphysics software in order to design finite element analysis. Second, for porcelain insulator material, the simulation is done in 2D drawing. Okay, third, the influence of the electric field distribution on the surface of a porcelain insulator on the environment. Okay, for outcome, okay, the expected outcomes of this project are first, power transmitted pattern characteristic in dry and wet conditions. Okay, lastly, the simulation result with respect to different scenarios while maintaining optimum performance. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alia Binti Mohammad Zailani, metric number CE190192. Today, I would like to present a technical summary of chosen concept, design and finite element analysis FEA simulation software. So, this is our chosen concept design of a porcelain insulator. Next, we have the detail of our chosen concept design, which contains aceh horn, porcelain disc insulator and guard ring. The technical summary of chosen concept design can see below in table 1. We have 132 kilovolt as the voltage system, 16 coupling sizes, 255 meter diameter, 146 millimeter spacing, and a creep edge distance is 220 millimeter. Material that we use is porcelain, type string insulator, and cap and pin as a fitting option. This is a table for our chosen concept designed using IEC standard XP100U100BL. In this table, we added the value of combined M and E strength 100 kilonewton, 7 Newton meter for impact strength, and 50 kilonewton for routing proof test load. Moreover, we added power frequency dry and wet withstand 70 kilovolt and 40 kilovolt respectively. Dry lightning impulse withstands voltage 100 kilovolt, power frequency puncture voltage about 110 kilovolt, 10 kilovolt for radio influence voltage data, 50 microvolt for test voltage RMS to ground, and 5.3 kilogram net weight approximate. So, a technical summary of finite element analysis FEA simulation software. The simulation was carried out using the console multiphysics software, and this software used finite element analysis to do stress analysis on a project site's numerous components such as voltage distribution and electric field. Furthermore, this software also can design electromagnetic structural mechanics, acoustics, fluid flow, heat transfer, and chemical phenomena in one environment. After the design of the insulator has been sketched, the material is set up to show the graph as the result of the simulation. In addition, it is starting from the pre-process which requires sketching the design and setting the parameters or physical quantities according to the chosen material characteristics of the insulator that need to be tested. Next, the process flows FEA simulation on the prototype. Firstly, we start with determine the type of insulator. We select 2D asymmetric space dimension in console multiphysics software. We add electrostatics as the physics interface. Then we select stationary as the study. We sketch the insulator design and define the properties of the materials such as terminal for 132 kilovolt and ground. Next, we mesh the model and compute the study. We show post-process results. If yes, we export the data, record and analyze data. If no, we have to sketch the insulator again. Lastly, we move to the design planning or design calculation. Each group's students must decide which types of insulators will be tested. This project's insulating portion has a diameter of 255 mm, a creepage distance of 220 mm, and a net weight of 5.3 kg. Define the model's material characteristic and boundary conditions before sketching the insulator design. The single glass cap and pin insulator is the subject of the first simulation. A simulation of a string insulator with and without contamination was performed. Repeat the method to simulate the performance of the arching horn and the string insulator. Lastly, the results will be shown in surface plots of the electric potential involved. So I think that's all for me. I will pass to the next presenters. Thank you.
My part, I will present the demonstration, and for this project we use console multiphysics software. Firstly, we have 4 conditions, which are string insulator without contamination, string insulator with contamination, string insulator with arching horns without contamination, and lastly string insulator with arching horn with contamination. Okay, firstly we have to sketch out the part, and for this one we use 90 insulator to build a string insulator, and after that we have to build a mesh and we have to compute in order to get the result. Next, after we compute, we get firstly for the electric potential for this project, and next we can get the graph electrical potential, and after that we can get the electric field, and this is the electric field that show. And first we have high electric field at first this, and lastly we can get the graph electric field, and that's for the first condition, which is string insulator without contamination. And next we can add the contamination to the string insulator. Firstly we have to add this and build the contamination, and we can see from this there are contamination in here. We can see the contamination. Okay, after we add all the contamination, we have to build the mesh, and we also have to compute. After we compute, we can get the electric potential for the second condition, which is string oscillator with continuation, and also can get the graph. As we can see the graph for the electric potential, and we can get also the electric field, and lastly we can get the graph electric field. Okay, next for the third condition, which is string oscillator with arching hand without continuation. So this is the sketch. We also slide this and we add the arching hand to the string oscillator. First we have to build a mesh, and we have to compute as usual. So this is the result for the electric potential for this condition. As we can see, the electric potential at this area is very high, and this is the graph for electric potential, and this is the electric field, and we can also get the graph electric field. And for the last condition, which is arching hand string oscillator with arching hand with continuation, we have to add the continuation to the object. As you can see, and here there are all the continuation. And next we have to build a mesh, and after build a mesh we have to compute to get the result. So as we can see, this is the result firstly, which is electric potential, and next this is the graph for electric potential, and this is the electric field for the design string oscillator with arching hand with continuation, and lastly this is the graph for electric field.
Assalamualaikum and have a good day to my fellow friend and Dr. Rahisham. My name is Mohammad Hakimi bin Othman. My matric number is CE190092. So I'm going to present FEA simulation result and data observation. So as we can see here, this is the design of a single porcelain cape and pin disc insulator that we have designed in console. So for the first one is we are going to see the performance for single porcelain cap and pin insulator. So as we can see here, this is the electric potential distribution. There are two colors, which is red and blue. The red is higher saturated area, and the blue one is minimum values for electric potentials. So this is the electric potential distribution. Next, for the graph, here we have two graph, which is electric potential strength graph and electric field strength graph for single porcelain cap and pin insulator. Next, performance of insulator with contamination and without contamination. So the first one is the design that we have designed in console for the insulator, and the blue one is contamination outside the insulator. So this is our insulator. So the blue one is contamination. So the second one is the mesh model for the design. So in here we have the result for with contamination and without contamination. So for the red one is the highest saturated area, which is highest value electric potential, which is here, and at the top is minimum value electric potential. This is for contamination, and this is for without contamination. Next is the line graph for electric potential, which is for the previous one. This is for with contamination and without contamination. So this is the graph, electric potential and electric potential distribution. So we can conclude that this is for the electric potential distribution along the insulator string. We can conclude that the electrical potential distribution after contamination has a slightly higher voltage than the graph without contamination. Next, contamination has an impact on the value of electric potential distribution. So this is the surface for electric field with contamination and without contamination. So as we can see, the red one is here, the highest saturated area, highest value electric field, and the blue one is the minimum zero electric field. Same goes to the without contaminations. So this is a line graph for electric field with contamination and without contamination. As we can see here, without contamination has a highest the electric field distributions here. So the electric field distribution along the insulator string. So we can conclude that when comparing the graph with and without contamination, the graph with contamination reveal a greater value of electric field norm. So that's all from me. And next, I'm going to pass to my friends.
My name is Mohammad Razin bin Hayadin, metric number CE190076. I will continue for the presentation for performance of insulator with contamination and without contamination along the insulator string with arching horn. This is the result that you get from the simulation for the mesh model for the insulator string design with arching horn. And next, for the with contamination and without contamination electric potential distribution result from the simulation. This is the surface of electric potential. And next, for the line graph electric potential, this arc length time to the electric potential with contamination and without contamination have a little bit different at the line graph for the electric potential distribution. And next, the electric potential distribution along the insulator string with arching horn. There is no noticeable variation in the value of electric potential in the voltage on the graph of electric potential for both situations. This is for the surface electric field norm for the with contamination and without contamination electric field distribution for this result at the simulation. And next, for the line graph electric field norm for the arc length time by electric field norm for this graph have a little bit different with contamination and without contamination. Without contamination have a ripple line at the graph. There is have a disturbance at that line. And then in comparison to the graph of the condition without contamination, the graph of electric field distribution with contamination showed a greater electric field number. Next, brief analysis of FEA simulation results and data observation. For the condition of insulator contaminated have a max voltage 130,690 volt, and for the minimum voltage is 0. For the non-contaminated, maximum voltage is 130,150 volt with a minimum 0 voltage. And for the highest and lowest value of electric field, contaminated max voltage is 364,000 volt and with the minimum voltage is 0 volt. For non-contaminated, maximum voltage is 353,000 volt and minimum voltage is 0. And this is the comparison between insulator with contamination and without contamination along the insulator string with arching horn. For the highest and lowest value of voltage, for the contaminated, maximum voltage 130,980 volt with the minimum voltage 0, and non-contaminated maximum voltage 130,450 volt with the minimum voltage is 0. And the highest and lowest value of electric field, contaminated, we get maximum voltage 361,500 volt and minimum voltage 0 volt, and non-contaminated maximum voltage is 360,200 volt and minimum voltage is 0. And that's all from me. Thank you.
Assalamualaikum and a very good day to everyone, especially to the lecturer, Dr. Rahisham. So my name is Mohammad Iskandar bin Batisah. The metric number is CE190083, and today I will be presenting about the conclusion from FEA work. So the porcelain insulator design in this project is one of the good insulators. This insulator's performance has been validated using FEA analysis simulation software, which is console multiphysics software that delivers efficient performance even in contaminated environments. The insulators must be tested with the high voltage test before being used in overhead lines to ensure that they can operate safely under the rated electrical conditions and that their insulation is effective. Next, HV testing proposal, safety risk assessment. Okay, so as we all know, before we want to conduct any experiment regarding the high voltage, we need to have the safety document risk assessment. So what is the safety risk assessment? It is a systematic procedure for identifying and managing hazards. The aim of the assessment process is to evaluate hazards, then remove that hazard or minimize the level of risk by adding control measure as necessary. By doing so, we can create a safer and healthier workplace. So as you can see, this is one of the example for the safety document. We need to fill up the particulars such as title of experiment, project or academic supervisor, and also the person carrying out the experiment. And also not to forget, we need to fill up the purpose of the experiment, equipment being used, and also the experimental procedure. So all these particulars need to be filled up before we conduct the experiment. And this is also another risk assessment and another safety document. So we need to fill up the form and we need to get approval by the supervisor or head of laboratory. This is the record of chemical usage within experiment. This is the hazard checklist and risk assessment severity matrix. So for the checklist, this is the checklist of the hazard that may occur during the experiment, such as the electric shock from high or low voltage, fire, high or low temperature, and so on. So we need to go through the checklist before and during we conduct the experiment. And also the risk assessment for the severity matrix, we can see that there is the risk classification value, value from 1 to 25. Next, HV testing proposal, code of conduct. The DC voltage source for the contamination test might come from a two-stage Walton-Cockcroft generator. As you can see, this is the circuit for the Walton-Cockcroft generator. The average flashover voltage may be computed as follows. So we can calculate the average flashover voltage by using this formula. Each equipment must always be tested to determine that it can tolerate overvoltage when in operation. The configuration must be appropriately grounded to avoid any potential risk. To limit the risk of electric shocks, apply protective clothing as insulated boots and gloves, and face protection should indeed be addressed as in case of a porcelain insulator cracking. Next, conclusion from HV testing proposal. The high voltage testing has proved the insulator's ability to sustain overvoltage based on the incidence of flashover with and without contamination. When doing the test, precautionary measures should be observed because working with high voltage is risky. Lastly, aside from avoiding unnecessary cost and equipment damage, a safety risk assessment must be undertaken to reduce hazards like as electrocution or burn to humans, which can result in long-term harm or even death. So that's all from our group. Thank you very much.